Everybody, it's Marty, the JavaScript party. I see that my mic is actually showing changes here. It's Rhett is with me. You can't see her. She's not a little bit off camera at the moment. She's to the right side. Oh, she just walked into camera. We are just chilling, coding. I definitely want to apologize for not having sound on yesterday. Um, but yeah, no, I guess it's kind of what happens when you're just like a one dude trying to make videos. Um, so I did want to yesterday I did talk a little bit about how basically when you when something like so this is drawing on my screen and it's being animated, but to our eyes, to most people, so in real life what happens is something will move and it'll move from one place to another and it actually crosses across every single spot. But you can't actually see every single spot because what happens is your eye, most people, their eye um, processes things at about 60 frames per second or 60 hertz, I believe that would be another way of putting it. Um, so every second, every 60 times, 1/60th of every second, your eye will take basically a photo. And then what happens is your brain sort of fills in the blanks. So what happens on the screen here is that the browser the browser updates this, but it doesn't update it. It jumps every 60th of a second. It's actually going pop, 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 pop. And the browser attempts to update the screen in the same pace. So then we get our eye basically fills in the blanks. Um, and so most people have computers that are in the gigahertz, like their CPU will operate like a billion processes per second, and a drawing stuff 60 times a second is pretty easy, right? Because one is doing like a billion instructions per second, and like the update of the screen is probably, I don't know, I'm literally just stabbing in the dark, but somewhere between every one of these things is maybe 10, 20,000, maybe 50,000 instructions. So once every 60 seconds it tries to execute these 50,000 instructions to update these things for our eye to see these things update. Well, so in this code, the way I've done it, this gets run. Yes, really, really, yeah. This gets run. Attempts to run this as part of something called the request animation frame, which the request animation frame runs 60 times per second. So, which so now, so there's that. Okay, that's like an important thing to keep in mind is that your processor is running at a massively fast time, and then this is attempting to run at a significantly slower time. Then when you're doing things in here, there's like calculations that you may have to do. Now the problem is that okay, so well, no, the thing to keep in mind is reading memory is optimized. It's very, very fast. It's not a lot of instructions. So anytime you do a read, it's going to be very light. But anytime you do a write, it isn't. It's a lot more instructions. So like adding two numbers is a lot, has to move a lot of things into a lot of registers. And then it has to, like, it does arithmetic in a way that's very different than we do arithmetic, and it's a lot of instructions to do arithmetic. So if you're trying to do calculations, the last place you want to do them is in something that is locked into that 60 times per second. Now, I also have this layout service. So the intention is that this can run whatever. You could do all the calculations you want in here, and the browser will figure out where to slide it in. It has complete flexibility in sliding in when all those things happen. So they could be happening thousands of times, millions of times per second, but um, but this guy over here is locked in to 60 times per second, and it's only because this visualization gets called as part of something called the request animation frame. So now normally what happens is, see this. animation service gets called as part of this request animation frame, and then basically it calls itself again, and then all it does is say, hey, on the next 60th second, can you do this stuff? And so that's just a really good way to sort of manage that, of saying, hey, this is the stuff I want you to do on that. But see, like this, all of these from line 46 to 52, they all happen like really, really fast. But if you tried to make them all happen on every 60th of a second, like, so I don't know exactly the best way to put this, but I'm just saying that there's some things that you could just say, hey, browser, just do what you want and do it when you want. And they figured that out pretty good. And then there's this request animation frame, and that piece is like locked in. It has to have, it tries really, really hard to do it every 60th of a second. So you don't want to put a whole lot in there because, like, so like when you move your mouse around, for example, the most I've ever seen, like if you move it really, really fast, is like 2,000 events in a second. Like if you try to do force a draw every 2,000th of a second, if you're doing some kind of thing every 2,000th of a second that is forcing a draw, it's going to cause the whole system to get mired up. Um, I've never really, I don't think that's a very good explanation. It's definitely one of the better explanations I've ever made, but you know, um, all I can do is just keep working on that. So, anyways, now in my, so right now what happens is I create these renderers, and these renderers have all the information to create one of these things, and then down here I go ahead and I actually add code for it to um, to know how to draw these things and when to draw them and how to animate them. But the problem is I want to have a layout, and I want that layout to figure out where to put these. And I don't really care, like if I do this and it has to do all these calculations, I don't really want it to update the screen every time. I just want it to update the screen once every 60 seconds. But I do want to do the calculations every time, because doing the calculations isn't that big of a deal. Isn't, the browser will manage that fairly well. I just don't want it locked into the request animation frame. I want it to be independent. And so basically everything that happens in animation service should be you should have it in your mind that this is something that is just only happens for every draw, and then everything that happens in the animate and the visualization, um let's see what a visualization layout, um let's see, let me go back to this view. Everything that happens in this layout service should be able to happen independently as fast as it wants. It doesn't care. You just go ahead and do it when you can do it. And it doesn't have to be locked in at all to that, because this is going to update when it updates, and it's going to look good to the eye because it's going to update every 60 times a second. So anyway, so in here, I guess what I need is a way to create a visualization. And the thing is what we learned yesterday, and I apologize because yesterday there wasn't any sound, is that this stuff here, these don't actually end up getting rendered on the screen until after an animation event, or after one of the lifecycle hooks. And we looked it up yesterday. Let me go to ChatGPT and look it up again. We learned that it is AfterViewInit. So those don't exist. What I want really is I want these elements, and they don't exist until after this AfterView event. So I can't have them until afterwards. Now, this is an issue that won't happen when you are manually creating them. But right now, we're just kind of, during the construction, in the constructor, we're running all these things. So these sort of concepts in memory exist, long, infinitely long in CPU time compared to when they actually exist on the screen. Um, so we have to wait till they exist on the screen because the elements that we want won't exist yet. Um, but basically, a view child isn't has an element ref, and that's what I want is the element ref inside of my layout, inside of my visualization. See, I want my element ref. And I did mention yesterday that I had to make this optional and this optional because I want to be able to, I realized I need to be able to export these things because if I am, like if I import one of these things and I had moved it to the middle and it was all big, when I import it, I want it to be moved to the middle and all big, and that information is going to be in this thing. But there won't be a renderer ID because the renderer ID gets created in memory, and there won't be an element because the element gets created in memory. So neither of these two will exist, so they have to be optional. Um, I mean, I guess there's other ways I could do it. I could have like another object that and then like extend this from that object and then bring those in. But this is kind of how I chose to deal with that, is by making these optional. All right, so basically, I guess I'm trying to figure out like order of operations from writing the code in the most understandable way. So I think what I want to do is go ahead and hope that it's telling me the truth and that after view init is what I want. So I'm going to say, I'm going to go into here and I'm going to say implements after view init. And then I'm going to, that is weird. Usually it will do, there we go. So now it just automatically built it for me. And I don't know, it used to build it at the top, but now it's building at the bottom. Or maybe it did always do it at the bottom. But I do like my lifecycle hook implementations to be right after the constructor. And since all I have is a constructor, this works out pretty well. Okay, so what we're going to do is we are going to do console log. Oh, let's see. What time is it? It is 8:09 and it is March 20th. 11 days left in the month. We are definitely in spring in southeast United States. In the southeast United States, we are in spring. Things are starting to bloom. It is getting to be beautiful. I think last night might have been our last 30-ish Fahrenheit night of the year. So it's an exciting day for me. Me and my wife actually discussed whether I should put some of the plants that I move in and out, like I'll move them in for the winter because they can't handle really cold temperatures, and then I move them out for the spring and the summer, and the fall, and then I bring them back in when it gets cold again. But console, um, let's see, children, and then children, comma, this dot, what was the name of those things? Should I call them visualization items? Let's go ahead and look back up here real quick. Children, we want to get, yeah, visualization item. And it's looking for a visualization, and I'm going to get a bunch of element refs. I could be more specific. I could actually say it's the kind of component, but I don't think that's necessary. So what I'm going to do is I'm going to hit save, and I'm going to look at our console, and I'm just going to make sure that sort of the world is as I expect it. So, oh, here's our visualization items. So basically we have a query list and I want to convert that into an array. And I think I did ask it yesterday how to correct it, how to love you too, right? Okay, I don't want the other way. I want like the sort of most readable way. I mean, I do like this. I like these new things like that, and that's pretty cool. But I would rather, like, you kind of have to know what you're doing. Whereas I feel like the other way where you can be, um, array using to array. I would rather do that because I feel like that's a little bit easier um, to do it. So, const children. Um, so that's an array of element refs is equal to this dot visualization items dot to array. So again, I just want to make it clear that I just feel like when you read this, you know what it's doing. I feel like I don't know. I don't know if this is faster or slower or all that, but like this is not English or any language. This is just like our sort of coded language. This is to array. So you have to know. I think that this is a little bit better. And then so let's look at children. I love you too, Rhett. Respect. All right, so here are our children. I feel like that's a little easier to deal with than the query list, but these are our children, and each one of them will have these things in it, and it's kind of wild. Viz component. Okay, so each one of them is like the entire Viz component. Um, so, and then I believe an element ref. Let's see. What we're going to do is we're going to say take our children and we're just going to iterate over them for each. And in this context, I just want it to be an element ref. I don't really care that it's child element ref. Child, comma, child. So now we get a child. We get basically all of our every individual child, right? And now an element ref, I believe, has a native element. And our native element, oh, see, and this is what I was afraid of because it isn't, the native element doesn't exist, and that is so this is the actual element, right? So, but it render view child. Is that the wrong? What? I feel like that might not be an element ref. See, because there it's empty. All right, so let's go ahead and put a debug. I think there's something I definitely don't understand going on here. See, there's this renderer view child, and that is an actual element ref. So I feel like, oh, so this is the whole component, not the. This is a viz component, not an element ref. View children, query list. Is it like this? Viz component. And then change that to viz component. Component and then child. And then what was the deal in here? It was a render view child. View child dot native element. Let's try that again. Let's see what we got. See what we get. And I guess we can get rid of this debug statement just so we can see what we have. All right, so this, so basically these are our elements. So we can set, I believe I could take this and I can set the width or the, like I can change, I could set its position based on with this a reference to this. So now these are viz components, not element refs. So let's go ahead and go into our visualizations and change this to viz component, and we'll import that and get rid of this. So when we create an ST visualization, every one of them will have a reference to the actual component in there. So, you know, unless it doesn't exist yet. And the reason it would not exist, the only reason it would not exist is if we're importing it from like a static file. So that was like, honestly, I don't think I understand this. You know, and I think there is a way that you can actually tell it to only get the element ref, like now that I think about it. So when we do this visualization, I believe that there's a second thing which you can do in here, and then ops read. I think there's something in there where I could have defined that it's going to be an element ref. But you know what? If we have the whole viz, a reference to the whole viz component, we might as well go with that. So now we have a list of these things. So now for each one of these children, we can now create an ST visualization. Let's see what time. It's 25 minutes in. It's 8:21. This is a very good time for me to call it quits. It'll also give me something interesting to sort of. This is probably like the last thing I think about every night before I go to sleep. I lay down and I just sort of think about what the next steps are, and I feel like this is a great spot to like sort of let my brain just sort of let what we just experienced seep in. Don't think this log is doing us any good anymore, but I do think we need the next one. So at this point, we want to create a ST layout. This viz component with a reference. And hit save. And that will do that. Everybody, happy coding. Have a wonderful day. We're almost to Friday. Bye.